Hello, can you hear me? Just doing a test on the microphone, making sure all the equipment are okay. Great, great, great. That's good news. So I guess it's already coming to the and we should be starting the session right now. So good afternoon and welcome to Works webinar titled The 7 Quality Tools That Every Quality Professional Should Master. It's a pleasure to be here today. I know it's a rainy day in Dubai and everyone is trying to get to the weekend as fast as we can. So I'll try to make this as painless as I can. To get this started, I'm very excited about presenting this webinar on the quality tools. I've been involved with the quality profession for over 25 years. And indeed, I've seen all these quality tools being used in every title. Every professional would need to use certain tools. And in the quality field, we have a number of these famous or magnificent, or some people call them the basic 7 quality tools. So if you allow me to borrow from my experience over the years and present to you what these tools are and how we can use them in certain circumstances and certain situations to improve on quality. So to get this started, maybe we can start with the quick introduction just about myself and the experience that I had over the years. I'm an engineer by profession. Civil engineering is my bachelor's, master's in industrial engineering. And over the years, I've been working on helping organizations to develop their quality management systems, working to helping them to audit their quality management system, and working to develop projects on improvement and Six Sigma and Lean. I've extensively worked in North America, in Canada to be specific, and I moved to Dubai in 2003 to join BSI, British Standard Institution. I also worked with IBM and joined Merck in 2004. I've worked in different fields from leadership, strategy, planning, KPIs, and of course quality, which is my favorite topic. And as you see here, I've worked extensively with many of the Fortune 500 companies in the region, in North America and in the Middle East. So to get this started, allow me to just take you through what we're going to be talking about today. First of all, we'll be discussing what's the concept of quality. We'll be talking about quality tools. So the next topic will be about tools. What is a tool? What is a quality tool? And then we will venture into the 7 magnificent quality tools. We call them the 7 magnificent quality tools because every project in quality that we do to improve something, to modify something, or to Kaizen something will be using some of these tools. Applications, we'll try to take your questions. We'll try to expand on the topic as you would like maybe to ask specific questions on these tools. So just to start this discussion going, quality will have different definitions. Many people will define quality maybe like doing things right the first time, every time. Some people may come in and say, quality is about customer perceptions and their expectation. Is it about meeting expectation or is it about exceeding expectations? Quality resides in the process that yields the product or service. We need to start focusing on the process that will give me the product or service. And you may add your own definitions on quality. I'm sure every one of us would have maybe a deviation or a modification on quality. As we talk about quality, we need to start talking about the tools. And every professional, whether it's a surgeon, or is it a carpenter, or is it an electrician, will have their own tools. They will carry their toolbox and they will use it to actually do their profession. Like all these professionals, quality has its own tools. Now, to define a tool, Webster Dictionary will define a tool as any implement or instrument that we can use or we can hold in hand, and we use it to shape, fasten, add, or modify, or improve something. So in quality, we can talk about these specific tools that can help us to achieve my or their project's objectives. It will identify trends and focus areas. It will analyze processes for stability and capability, we can use it to identify root causes and identify true root causes once we work in any project to try to define what is important for us. We can use tools to identify statistical patterns, distribution, and variance. For a process, we may be interested to know more about the outliers or distribution of a process, to try to understand whether it follows a normal distribution, maybe, or a non-normal distribution, and we can use that in our process capability calculation for the future. So there is a mix of statistics, there's a mix of logic, and there is a mix of problem-solving tools. Here is me, and just adding in that people usually, when they use their tools, they may know one tool and they might use that tool all the time. I'm just saying here, do not pick up your hammer and start pounding. Decide what you want to build first and then choose the right tool that will achieve your goal. There's always this question, what is the best tool? I mean, there might be, I would say, more than 180 tools that can be used in the quality profession and the quality field. What is the best tool? Is there a best tool? So we'll try to answer that question as we get into the tool discussion. We'll try to remind me to answer that question to you later on. Well, here are the tools. And again, I'm trying to identify which tool I should be using for what purpose. Well, I think the question is, why do you want to use a tool? What is the purpose? Are you using a tool to define a project or a scope? Or are you trying to define the root causes? Are you trying to run a qualitative analysis of the issues or causes for a pain or a deviation? Are you trying to define what we call maybe a pattern for a distribution or a process behavior? Maybe we should be using something else. So again, we try to link the tool to the purpose. And here is something I borrowed from a book called The Quality Toolbox by a lady called Nancy Tagg. And in her book, she actually goes through the tools and she talks about the different aspects of the tool. For example, if you want to use a tool to define a project boundaries, scope, you want to identify maybe the objectives, you want to discuss the process beginning and the end. Maybe we could use something like a project charter as you see here. So if you come here and you can see that maybe the project charter is what we seek. Maybe you're interested in deciding or building a project plan, maybe a Gantt chart. Or maybe someone is interested to discuss the pros and cons or drivers and constraints for a project. This could be the force field analysis. So as you see here, we have different tools that could fit under what we call the project planning and implementation phase. And the tool will also tell you that I can be used to define something called the current state, or I can use it for changes, or I can use it to monitor. So as you see here, we have a number of applications for such a tool. Same thing here, you have maybe tools to help us create ideas. I am interested to discuss with my team on how we can come up with creative ideas. So maybe we can use idea creation tools, from mind mapping to Scamper to maybe using a picture association or biotechniques or brainstorming or brainwriting, affinity diagram. Tons of tools that we can use in the idea generation toolbox section. We move forward and we have some tools to help us with process analysis. So I want to understand how my process works. From maybe a high level, a forest view, I can use maybe a SciPoc, I can use some kind of a simple flow chart here, I can use an MVA or a value stream mapping. Tons of tools under the process analysis section. Maybe I'm interested to collect data and present my data in a pattern or a graph that shows me behavior over time. A run chart, a histogram, cycle time, all these tools, or a box plot as well, can be used to help me identify patterns. And as you notice here, you've got a list of tools under causes, root cause analysis, from Fishbone to fault tree, FMEs, and the list goes on and on. And as you notice here, even tools that we can use for decision making, evaluation of improvement tactics, and deciding which tactic is the right tactic for us to apply at a certain time. Now, where would you use these tools? Would you use them to identify a root cause? Would you use them to analyze a statistical behavior, something here, or would you use them for a root cause analysis? You've got all these tools. Now, the issue is, which tool should I use when? So what we will do, I have picked a number of these tools. As you see here, you have more tools, you have techniques, you have the 7 basic quality tools. I've picked here what we call the 7 basic quality tools, or there is a deviation from that, which is the 7 magnificent tools. So I've picked a number of these tools, and we will go through them one by one just to make sure that we have a good coverage. The picture of this gentleman is a Japanese guy called Kiro Ishikawa, the guy attributed by developing these tools and making them available for us in quality control, where he basically wanted these tools to become available for everyone, to be used in every type of industry. So we will go through them, and we will talk about the applications, and then we can take, of course, your questions. The first tool that we will start with is the check sheet. But before we do that, maybe we can get your participation, or maybe run a quick poll on which tools you think that could be available, or you're using them here. So let me see how do you see the poll? Yeah. So pick the tools that you can basically, or you have used before. Maybe you can pick more than one. So, all right. So, is it histogram that you continuously use? Is it Pareto? Is it cause and effect? And let's see how that goes. All right. Getting everyone here. All right, interesting. I think we have, okay, 10 seconds. All right. So let me see. All right, we're gonna end up the session and voting and see which tools are there. So let me show you the results. I mean, it's usually common to see such results, but here are the results that you can see. And it's interesting to see that one of the top tools that I often see in projects of quality is the cause and effect diagram. The cause and effect diagram is what they refer to as the Fishbone or Ishikawa diagram, and we'll see that in a minute. But it is one of the very simple tools. It's called the Fishbone or the Ishikawa cause and effect. And the check sheet is another tool to collect data. You can see that some people use a little bit of histogram, which is a statistical approach to look at data and variation. And then you have also the flow charts. So let's see. I mean, it seems here we have others as well, but let's look at these tools and try to see whether you use them, or maybe we can learn more about these tools and how to use them. So as we said, the first tool is a very simple tool. It's called the check sheet. It is basically a tool to help us collect data and to make the tool or the data collection process more structured, so we can take that data and use it later on to maybe create another tool, which is the Pareto or a control chart. For example, you're interested to take data on the late submission of a process in a company, and you are trying to count how many of the late submission items were related to computer down or too busy or lack of training. So you can basically take this data, which is here, and you can use it later on maybe to generate a Pareto chart or something similar like a bar chart as well. So simply put, it is a tool used to collect data and make data collection more structured and more available. This is mainly used when you have teams trying to sample and trying to get more data. The second tool, which is a very important tool for us, requires a little bit of building what we call a histogram. Now, a histogram is a tool where you count and you use your counts over here and you try to create what we call buckets. The buckets will capture, for example, you want to sample in a time where you have in a room certain participants or company staff, and you want to build a histogram of their ages. So you might have a bucket that shows you that here we go, 20 to 29, and then 30 to maybe to 39, and then you have buckets where you're basically trying to count how many do you have in each bucket. Now, as you create a histogram, it becomes very useful for us. It is showing us what we call the spread from here to here. It is showing us whether we have what we call outliers, and indeed, it is showing me if I can create something. Let me try this out. What we refer to as a normal distribution, and we can use lots of the theories in normal distribution to actually forecast and predict a process behavior. Very useful tool graphically. Softwares can immediately create these histograms, and we can use them to compare between one process and another process. You can even see here, maybe there is some kind of a center point where most of the data are centered or targeting, so we can see what we call a deviation or a spread between the data points. You can use the histograms, as we said here, to start to calculate what we call the X bar, which is our average. You can calculate the standard deviation. So there is lots of statistics that we can pull out of a histogram to help us understand the process behavior and the process variance. This is why we use a histogram. What we can learn about the process changes. We can understand if there is a concentration around a target, a spread, range, and distribution, and we can compare processes after the improvement has been introduced, especially in projects such as Six Sigma, where we can show you that the process has indeed changed from maybe a lower quality metric or a level to an improved quality level. You can see here different shapes, different spreads, and the distribution might be skewed to the left, skewed to the right. So you've got here, as we can show you here, this is normal distribution, this is the bimodal, and here is what we have skewed to the right. Maybe you have a tendency of a process to be near a boundary point. It can identify as well maybe issues such as what we call data collection errors. Someone has been collecting data but forgetting to log in, or they just ignored the data that we have here. So this is called sorted out. Outliers. Lots of information we can read from a histogram. Indeed, it is a graphical tool, but we can use it to read into the process, and we can learn a lot about my existing process. Another great tool, it's a statistical tool developed by a guy called Walter Short in the 1920s, and it is a tool to help us understand the process variation and something that we refer to as the stability of a process. Stability means a process will exhibit a normal variation. We refer to that as common variation, opposed to a special variation. And the whole essence and the discussion that happens here is to show a process after you have measured the Y or the metric you're trying to measure, whether that's a temperature or a dimension or a cycle time for a process, and then plotting it on the control chart where it will start to show you upper control limits, lower control limits, and indeed the variation between the upper and the lower control limits. The basic concept behind control chart that we try to get the control limits between 3 and -3 and +3 sigma, 3 sigma from each side, capturing 99.73% of the process behavior. Now, if you look at why would we use it? Well, it is helping me to establish common cause, i.e. whether my process is showing normal variation, which is shown in every process, and comparing it to what we have in terms of a special cause where something might be existing because of a one-off scenario like power failure or a traffic jam, something that is affecting my process but only for an assignable cause. It can compare, or we can use it to compare before and after an improvement, and it can show me whether you have points appearing outside of your control limit, showing me that your process is not stable, hence we need to come back and review my process for improvement. And here's an example. This process here, this is one type of the control charts. You can see the process variation. Now, this type of variation would be accepted as normal variation, and you can use it here basically to understand that the process is showing variation, but still within my limits, and that is telling me that the process here, or the Y or the metric I'm looking at, is showing what we call normal variation. Now, my objective, if I'm looking at normal number of defects here, will be to basically establish later on maybe a reduced what we call chart, so we can reduce the number of defects over time. Remember, control charts are showing you performance over time. Now, here's another example generated from a software called Minitab that can help us develop all these control charts and can show us exactly what are the points, and we can use it later on for variation control. So as you see here, upper control limit, and we have different types of control charts depending on the sample, depending on the type data. So we've got lots of softwares that can help us actually construct these control charts and make them available for us very quickly for further analysis. Another example here, we've got what we call X bar R chart, we've got X bar S chart. As I mentioned, we have a number of these control charts that can help us identify patterns and can identify issues with stability in processes. Here an example of a control chart. However, we can immediately see that something has happened here. Could it be a shift change? Could it be a material change? Could it be just lunchtime? People are, they just came back from lunch and their productivity is not very high, so they're having issues with doing a certain job. And then it can show me here that something happened that has reduced the mean of my target. Very visual and very effective in identifying change. Why do we use it? As I mentioned, to look at stability and to monitor. Another word is to monitor. We use it later on for something we refer to as process capability, i.e. the capability for a process to continuously meet the customer needs. So this is a little bit of statistical analysis that we do to establish something called the CP and the CPK. Another tool that I often find in projects is called the Pareto analysis, named after the Italian scientist Vilfredo Pareto, who discovered a relationship which we refer to as the 80-20, and where 80% of the land was owned by 20% of the people that were at that time. And he said, if we can discover this relation, this would be very useful for us. So we took this rule and we started creating what we call the Paretos. But what we did here, we basically started putting the highest count on the left, hence creating what we call a Pareto analysis. The whole idea from the Pareto is to identify the 20% that are causing the 80% impact on my process. Depending on what you're trying to measure, it could be you're measuring the number of complaints in an organization and you're sorting them in categories. So you can say, well, I'm getting here like 50%, I'm getting here 25%, so that is my 75% of my complaints that are happening in this area. It could be a call center trying to look at the patterns of their calls and where do they come from, so you can see that maybe 80% of the calls are coming from 20% of the countries. It's a very useful tool to focus your effort on what is important. And here's the guy, the Pareto, Alfredo Pareto, who basically came up with this theory, and till today it is proven to be true to some extent. So 80% here again, the 80-20 rule. And we use it, as we mentioned, to try to filter or try to focus on what is important for me, maybe in a project of quality or whenever I'm trying to solve a certain issue. This is a guy called Joran, one of the gurus in quality, and as you see, he basically polished or used this Pareto chart extensively to try to identify the 80-20. An example here could be that a company is trying to define the most frequency or type of errors and defects, and you can see here from the percentages that maybe these top 3 here will be the around, you know, the 80% of what they are facing in terms of number of defects. So you have frequencies and you have here the type or categories, and hence you can develop a Pareto chart. A very useful chart for us. Another great tool, I think this came in the survey, that most of you would tend to use the Fishbone. This tool has 3 names actually. Cause and effect diagrams, because it's trying to link an effect and trying to identify the causes. It's called an Ishikawa diagram, and it is called the Fishbone, because some people like to refer to it as the Fishbone. Now, what you want to do here, you want to put your problem statement. Why do employees come late to work? And you can start using here the analysis under the manpower, the people themselves, the measurements, if you have any, Mother Nature, environment, and the methods, maybe procedures or policy discipline. And what you want to do here, you want to go to the manpower, which is the person himself in this case, and try to say, well, why is he not coming on time? Is it lack of discipline? Is it they're not committed? Is it they don't enjoy work? They're not motivated? And you can start developing a qualitative analysis of the issue to try to later on isolate the true root cause in your analysis. Here's your fish. That's why they call it the Fishbone analysis, because once you start doing the effects, you can start doing the bones here, and you can try to answer the question to focus on the effect. So here also talking about why, how do you need it, and why can you use it. Here is also the guy Ishikawa that used it in many projects to identify the 6 M's, we refer to them. 6 M's. Now here are my 6 M's. Now environments tend to become Mother Nature, so we can use the M in such situation. Okay, we are moving here to I think the last, or maybe we still have 2. Let me move to the scatter diagram. Scatter plot is another tool that tends to show you the relation between X and Y. Now, X and Y, they have to be continuous, they have to be variable. And it tends to show you a correlation between the X and Y. This is considered strong positive correlation, moderate, weak, or it tends to be negative correlation, i.e., once you increase X, Y will tend to increase. All right. Now, there's a very important rule here. You need to be careful not to tell or show that correlation is leading to causation. That is the wrong conclusion, because correlation does not mean causation, i.e., X is not the factor that is causing Y. You're just showing a relation or a correlation. All right, moving on. This is the tool that we like to call the flow chart or the process map. And indeed, many times we will think my process is like this, while it is actually like this. Based on an audit, we discover this is my audit. Now, what is the purpose of a flow chart? Is to showing us the flow, non-value added activities, duplication. My objective through a project in quality using this tool is to challenge these steps, try to remove them, try to maybe combine them together in an effort to move the process to a should be. Now, the should be is open for more improvement, where we could actually use a could be and it become improved after the should be. These are the common flow chart symbols that we use for a flow chart. Very effective, very visual, and it gives us lots of information on the process to be improved. To build a flow chart, here's an example in one of my workshops where people are using sheet of paper, large sheet of paper, post-it, magic markers, and you can see here that they're trying to build something called the swim lane, which is one of the types of flow charts, and trying to show you the flow between the steps. Here's another example of what we call the forest view, where you get the whole organization in one snapshot, showing you what's happening and how the flow goes across the organization to the delivery of a service or a product, showing you all the support services and departments. Now, here is an example as well of a swim lane. More example. Here's an example from one of my sessions. The participants are very busy doing, the as is, doing the should be, and here is the result here, where they are showing you an improved state using what we call the swim lane process chart. A very useful chart or a very useful tool. So I guess we've just covered the 7 tools, and I know there are many other tools that can be useful for us, but maybe we can just tell you a little bit here, and then we'll take your questions, of course. Takeaways. I mean, as I mentioned, maybe there are more than 180 tools, and quality professionals will need to know about them. However, knowing maybe the 7 basic tools, the 7 magnificent tools, will help them a lot in their projects. You need to decide what is the right tool for the situation, and then select that tool for that specific purpose. You may want to use tools for qualitative analysis, such as the Ishikawa or cause and effect, or sometimes you may want to use data. So you can use the histogram, you can use the control chart, and these are the ones, the quality 7 tools, or the 7 quality tools that should be in your box all the time, so you can apply them at any stage. And the more tools you know, the better quality professional you will become. Now, to answer my question maybe, and then I'll take your questions, what is the best tool? Would you like to share? Did you feel there is a best tool? Can you answer this question? Is there a best tool? Did you like anything? Is there one best tool that works for everything? Any ideas? Is there a question for that? Or there's an answer for the best tool? Many people will tell you maybe, well, there's no one best tool, but the tool that works best for the purpose of what you seek to achieve is the best tool for that situation. So there's no best tool that can be used for everything. It is the purpose, it is the situation that you want to use it for, and that becomes your best tool as such. So I'd like maybe to get here to the last slide, where I can take your questions. If you have any questions, please write your questions, and I'll be more than glad to answer your questions.
Oh, sorry.
Go ahead. Don't be shy. Any questions on the tools, the control chart? All right, any questions? So, is there a best tool? Anything you want me to elaborate on? I'll be more than glad to answer questions. And, many of our Merck courses, of course, are, addressing these tools. We've got a number of courses, the TQM Toolbox. We've got specialized courses on the statistical mode, such as the Six Sigma analysis, where basically we can, answer more questions, and we do lots of applications using software and specific, applications and examples and case studies. So feel free at any time to email me at fbawab@Merck. Let me write you my email here. And you can basically, all right. Oh, here we go. Which is the most common used tool? So I see your question. We've only seen that you've shown us an example of flowchart from your workday. Which is the most common from all tools, or from 7? Did you mean, Fernandez? Is it you've only we have only seen that you've shown us an example of flowchart from your workday? Are you talking about flowcharts? You're talking about let me just clarify that from Fernandez. In flowcharts, we have also a number of different types of flowcharts. We've got something called the SciPoc. We've got the swim lane that I've tried to. All the 7. All right. So which one is the most common? As you've seen from even the survey that I did early in the presentation, cause and effect tends to be one of the most common tools. I see a lot of the Pareto. So I would, if you want me to rank, cause and effect would be one of the best, one of the most common, I would say. Pareto chart would come next. These are the top 2 I almost see in every project in quality improvement, even in root cause analysis in ISO, even in Six Sigma, people tend to use them. As you start to get more familiar with the statistical approach, then you can actually go to control charts, you can go to more tools, but I would say cause and effect, Pareto, flow charts, of course, is well known for people who are doing their documentation and procedures and processes, so many people are familiar with these. So I think these are the top 3 if you want my opinion on them. Thank you for the question, Fernandez. And Doreen did not have a question. I think I've seen something from Doreen. Thank you, Doreen. All right, excellent. Thank you. All right. Any other questions? All right. Oh, okay. So we've got one more question. Could you please clarify on when a Pareto chart could be best used? All right, that's a good question. Thank you, Talin. Well, we use Pareto when we want to identify the 80-20 rule. For example, someone wants to know what is the 80 in, say, in a number of issues that are being received by an organization. So let's say they're receiving feedback from a number of their customers, and they want to put them into categories where they want to understand whether these customers are by a country or by a nationality. So they actually can club them, and they can come and say 80% of the feedback or maybe the request that is coming into our company is coming from what? coming from a certain nationality or coming from a certain geography or a country. People can use it to give you statistics that 80% of the houses or the property, for example, in Dubai, where we are today, is being bought by 20% of the nationalities that are in Dubai. So you can use it actually to find relationships and to focus on what is important so you can make the right decisions. I hope that answered your question. Great. So, all right. So I think, thank you very much for coming to the webinar. Hopefully we'll have more of that. And, oh, I see someone typing. Okay, thank you very much. And we'll hopefully meet with you or see you soon, inshallah. Thank you and have a great afternoon and have a good weekend.
Merck.com